In this video, I'm going to show you how to use C++ Builder exe3's 64-bit C++11 compiler to work with the Boost library and the C++ 2011 language. First, let's take a look at the Boost homepage. Boost is a set of peer-reviewed portable C++ source libraries. Many of the Boost libraries have also been included in the C++11 standard, particularly in the Technical Report 1 library that has been approved, and some more of the Boost libraries are proposed for TR2. In this video, I'm going to use the Boost algorithm library, particularly the C++ 11 algorithms that are listed here on this page. All of, any of, none of, one of, is sorted, is partition, and the partition point. In order to use this C++ 11 Boost library, I need to create a C++ 64-bit project. There's an easy way to do that. Just say File, New, FireMonkey's Desktop C++ Builder Application, either HD or 3D. So you just go over and say Add Platform and choose 64-bit Windows. And you can remove the 32-bit Windows platform. Now you've got a project that you can use to build a C++ 11 compatible application. Instead of starting from scratch, I'm going to show you a project that I recently built that uses the Boost algorithms library and the 64-bit compiler. So let's open up my CPP Boost algorithms application. This is a FireMonkey HD application. It's got a few buttons. This button to add numbers in this edit box to this list box, and also a button for clearing the list, and then a button for testing all the different aspects of the Boost algorithms library, and also an edit box here for inputting a number to see if anything is equal to that number in this list over here. Instead of edit boxes here, I'm going to use the T number box, and the T number box is an edit box where the data entry is restricted to only putting in numbers. Let's take a look at the code underneath. First is the add button, and all the add button does is takes the number box's text property and stores it in the list box's items. And then I have a few functions defined: is odd, is even, less than 10, and greater than 10. And these functions simply return either true or false. The clear list button simply calls the clear method for the list box items to clear the list out. And the test button does all the work of using the Boost algorithm library functions. So first thing I do is clear out a memo. The memo is there to produce the results of using the algorithms library. Then I say if the list box items count is greater than 0, then there's some items in the list box, so there's something to use for my tests. If not, I just output into the memo box that you need at least one item in the list in order to do some kind of testing. If the list box count is greater than 0, meaning there's some list box items, then I create a vector to hold the numbers. And then I go through the list box count, and I take and convert the string text of the numbers that you put in from the strings array in the list box, and I push those onto the end of the vector by calling numbers.pushback. And then down in the code, I do the different tests of the library functions for the algorithms library. For example, these are a set of all of tests where I say if the Boost algorithm all of, so if the numbers are odd, by using that function I created is odd, then I'll output a string all the numbers are odd. If Boost algorithms all of numbers are even, so passing the vector and the function, then I'll say all the numbers are even. I can also use a range of elements in the vector. In this case, numbers begin and numbers end, so all of the numbers in the vector, and ask if they're even. And then I can also take that second number box and see if any of the numbers are equal to that value that I put in the second number box. So I can also call all of equal using begin in the vector and the first three entries of the vector. So going from numbers begin to numbers.begin plus 3. Here I'm going to see if the first three numbers are equal to the number in that second number box. And if that's true, and then output the result. And finally, I'll say all of numbers.begin plus 3. Just see if the first three numbers are even. Here's a couple of any of tests where I use the boost algorithm any of to say, are any of the numbers odd? And if they are, then numbers are odd. So passing the vector and the isOdd method. I also test to see if any of the numbers are less than 10. So if any of the numbers are less than 10, I'll produce that line. There's also library functions for none of tests. So I'll ask if none of numbers are odd, then I'll output that result. So boost algorithm none of. And there's also none of equal. In this case, I'll say if the first three numbers, so numbers.begin to numbers.begin plus 3, so are any of the numbers not equal to the number in number box 2? If that's the case, then I'll produce the result none of the first three numbers equals whatever number I put in. There's also one of, and that means one of and only one of tests. So I'll say if one of the numbers is odd, then I can produce one of the numbers is odd. And if one of the numbers is equal, in this case, I'll pass a range, the numbers.begin to numbers.begin plus 3, to see if one of the first three numbers is equal to that second number box. Is sorted tests are also included in the boost algorithm library. So I'll see if the list of numbers that I put into the list box is sorted, meaning it's in ascending order, then I'll produce the result, the list of numbers is sorted. I can also see if a range of numbers are sorted. So I'll say boost algorithm is sorted numbers.begin plus 3. So if the first three numbers are sorted, and I don't have to care after that fact, then I'll produce the message. There's also a library function for is increasing. So are the numbers increasing throughout the vector? And if the numbers are increasing, I'll produce the message, the list of numbers is increasing. Meaning there's no numbers along the way that are lower or less than a number. There's also partition tests to see if the numbers in the range, or in this case in the vector, is there a set of numbers that are odd in the list of all the numbers? And if that's the case, then the list of numbers is partitioned odd. And finally, there's a partition point test. And the partition point test says passing in a range of numbers, and in this case, I'll use the whole vector, numbers.begin to numbers.end, and I'll use that function less than 10, returning true or false. So if I find any numbers in a row that are less than 10, where is that partition point? And if I get that partition point, then I'll take that partition point and I'll subtract it from the beginning of the list, and that'll give me the partition point in the list of numbers, and I'll convert that to string and output it along with the message. And again, this code takes advantage of C++11. You'll see header files up at the top here, boost algorithm CXX11, all of, any of, none of, HPP, one of, is sorted, is partition point. So I'm using the C++11 libraries that are part of Boost 1.50. All right, so let's take a look at this C++11 Boost algorithm library test built with C++ Builder 64. So we'll add some numbers to the list. 2, 3. You can also then use the mouse. If you hold down the mouse button and drag to the right or left, you can set the values of the number box. And let's click the test button and see what we have. So it says any of the numbers are odd. Yeah, we've got 1 here, number 3. Any of the numbers are less than 10. Yeah, we've got 3 of them less than 10. One of the numbers is odd. One of the first 3 numbers equals 0. That's true from the 0 box. The list of numbers is sorted. Yep, it's sorted. It's in increasing order. The list of numbers is increasing. Yes, it is. And the partition point for less than 10 equals 3. 0, 1, 2, 3. That's the point where all the numbers are less than 10. And then this number 20, of course, is greater than 10. If we clear the list and hit the test button, it says you need to have at least one item in the list. So let's go again and let's put some data in the list box. 1, 3, 5, 9, 11. Click the test button. All the numbers are odd. Any of the numbers are odd. Any of the numbers are less than 10. None of the first 3 numbers equals 0, because 0 would be an even number. The list of numbers is sorted. it's increasing. And the partition point of less than 10 is the fourth element, 0, 1, 2, 3, 4. That's value 11. And one last test here. We'll just pick a bunch of numbers at random by sliding the mouse back and forth. And let's put the value 20 up here and click test. Any of the numbers are odd? Yeah, we have several odd numbers. And the numbers, any of the numbers are less than 10. Yep, we've got 4 that are less than 10. None of the first 3 numbers equals 20 because the 20 value is the 5th item in the list. And the partition point for less than 10 is right here at 0, the first partition, because there's nothing as we move along the way that's less than 10, the first item being equal to 10. So that's just a very quick look at how to use Boost and C++ 11 in the 64-bit compiler.